All right, let's get right into it. Welcome to This Explainer. Today we're unpacking a really fascinating topic, the architecture of digital identity and trust verification. We're going to completely decode how modern decentralized systems manage to strike that elusive, perfect balance between preserving your privacy and ensuring verifiable trust. It's a brilliantly elegant system of cryptography and progressive trust, so let's map the whole thing out.
Okay, let's dive into this. Here is our blueprint for the explainer. First, defining digital identity. Second, core identity primitives. Third, the ladder of assurance. Fourth, enrollment and action binding. And finally, balancing privacy and security.
Section 1. Defining digital identity. It's time to rethink who you actually are on-chain.
Think about it for a second, and we really have to throw out our traditional real-world concepts of identity here. When you're operating in a decentralized network, what actually links your actions to your identity? I mean, there's no central boss looking over your shoulder, right? So how do you actually prove you're the one pulling the strings?
Well, it boils down to this. Identity is basically just the cryptographic link between an actor and their actions. It's not your name, it's not your physical address, it's this rock-solid, verifiable bond to what you do, whether that's signing contribution fingerprints, staking assets, accessing restricted datasets, or, receiving payouts. You are fundamentally defined by the actions you can cryptographically prove.
Moving on to Section 2, core identity primitives, the building blocks.
Now, what's really interesting here is looking at who or what is actually taking these actions. And amazingly, the entire ecosystem fits into just 4 basic primitives. You've got your standard wallet addresses, just regular cryptographic keys. Then you have W3C DIDs, or decentralized identifiers. You've got organizations, which usually act as a single identity through delegated keys or multi-sig setups. And get this, you even have agents. We're talking autonomous actors on-chain. So whether you're a human, a massive global corp, or just an automated AI script, you're using the exact same underlying identity infrastructure. Pretty cool, right?
All right, Section 3, the ladder of assurance, or progressive trust.
So the system doesn't just shove you into a one-size-fits-all box. Instead, you basically climb this ladder of verification based on what you actually need to do. By default, you're at the bottom. You're pseudonymous, just proving you control a key. Simple. Step up a rung, and you can optionally link accounts, like your GitHub or an email, just for a bit of continuity. Climb higher, and we bring in verifiable credentials, or VCs. Think of these as third-party attestations, like a digital proof of a medical license. And finally, at the very top rung, we have full KYC or KYB. This is tied to your real legal identity, but, and this is key, it's strictly reserved for highly regulated datasets.
You might be wondering, why bother? Why verify and climb this ladder at all? Well, it's a calculated trade-off, and it's entirely up to you. Going higher up the ladder unlocks higher impact work. It boosts your reputation weighting. But hey, if you're just doing open tasks, you can stay right at the bottom, keep things totally pseudonymous, and preserve your privacy. You literally only reveal what is absolutely necessary.
Section 4, enrollment and action binding, the user journey.
How does a user actually navigate this day-to-day? It's a super logical flow. Step 1, create an identity. Step 2, link your wallets. From there, it's really choose your own adventure. Step 3 is connecting optional accounts. And Step 4 is adding those VCs or KYC if a specific dataset requires it. Finally, Step 5, you set your payout address because, you want to get rewarded for your work. It is a completely modular journey.
But here is the absolute crucial point. It's an unbroken invariant of the whole system. Every single contribution fingerprint, or CF, is signed by exactly one identity at creation. No exceptions. Even if a massive team is using a multi-sig setup, that team identity acts as the one single signer. It creates this perfect, fully auditable binding between what happened and exactly who did it.
Of course, we live in the real world, and let's be honest, we all know that sheer panic of losing a private key. Thankfully, the architecture handles this beautifully. You can safely rotate compromised keys. Because the system's history is append-only, all your past hard-earned reputation, it's fully preserved and auditable under your old signatures. Meanwhile, any new actions just seamlessly use your updated keys. You're not going to lose your whole digital life just because you misplaced a hardware wallet. Which brings us to Section 5, balancing privacy and security, the guardrails.
This brilliantly illustrates the core tension a system solves, keeping user data private while satisfying strict system access policies. So by default, the state is minimal disclosure, basically pseudonymity. But what happens when you hit a strict policy boundary? Say a dataset literally requires you to be a licensed clinician.
Instead of handing over your passport and all your raw personal info, you just present a verifiable credential. It gives cryptographic proof that you meet the criteria, the gatekeepers are happy, and your sensitive data stays completely encrypted. It's a win-win.
And as you're doing all this interacting, you're constantly building your reputation. Now, this score doesn't just come out of thin air. It's driven by three specific things: your verification level, on that ladder we talked about, the past accuracy of your work, and your staking. Staking is basically putting your money where your mouth is to back up your actions. The stronger your identity across these three factors, the more high-value work you can unlock.
Now, to protect that valuable reputation, there are some serious security hygiene practices built in. We're talking hardware wallets for high-value operations, two-factor authentication enabled across the dashboards. For those autonomous agents, strict least privilege keys. They get the exact permissions they need for their specific job and nothing else. Plus, the whole thing is backed by a really strict documented playbook for when keys do get compromised.
I really want to highlight this core invariant because it's so fundamental. Minimal disclosure, reveal only what policy requires, proofs live in evidence and signals when possible. This isn't just some neat little feature, it is literally the governing philosophy of the entire trust architecture. Every single design choice is made to ensure you never, ever overexpose your data.
So as we wrap up this explainer, I'll leave you with this thought. Seeing how elegantly this architecture handles verifiable credentials, selective disclosure, and progressive trust, with these tools available today, how much of your own digital footprint are you unnecessarily revealing right now? It definitely makes you rethink what the future of our online identities should actually look like. Thanks for joining me on this deep dive, and keep asking those big questions.